Welcome to the Deep Dive, where we take your source material and distill the key knowledge so you can get well-informed, fast.
hmm
Today, we are tackling resilience, that quality that allows some people to, navigate stress and bounce back from adversity, while others seem to get flattened.
It's really the question everyone asks. Is resilience a fixed trait?
Mm.
Or some people just, well, born with it?
Right.
And the answer, based on the neurobiology you provided, is a resounding no.
Mm.
Resilience is absolutely a skill, like playing the piano or running a marathon.
And crucially, the sources argue that these strategies, everything from how you talk to yourself to where you take your lunch break, they don't just feel like they help.
Not at all.
They cause sustained, measurable physical changes in your nervous system. And that mechanism, the brain's ability to constantly adapt, that's neuroplasticity.
Exactly. Our mission today is to look at the specific evidence-based strategies that physically rewire the brain structures responsible for how we handle stress and fear.
So we're moving resilience from just a psychological concept
To a biological outcome.
Yes. Okay, let's unpack this. Before we even get to the interventions, we have to understand the foundational structure. How is the brain set up to handle or, mishandle stress?
So we use what's called the dual system view of the brain. Think of it like two operating systems constantly running.
Okay.
First, you have the quick automatic X system. This is housed in the older limbic structures, primarily the amygdala.
The amygdala.
It's responsible for impulse, craving, pure emotion, and that super fast fight or flight response.
So the X system is the immediate gut reaction. It's the part of your brain that sees a deadline or hears a loud noise and just instantly hits the panic button.
Precisely. It is fast, it's efficient, and it's often wrong in modern life. Then you have the slow, deliberate C system.
Okay.
This lives in the neocortical regions, mainly the prefrontal cortex, or PFC. This system handles self-control, working memory, language, and intentional problem solving.
So the C system is the executive, the cool, rational head of the office.
It is the regulator, and the entire process of resilience training, in neurobiological terms, is all about strengthening the C system's ability to exert what we call top-down control over that automatic X system.
Right.
When you're resilient, your PFC is successfully telling your amygdala, hold on, we've got this, stand down.
So if strengthening that control is the goal, what specific real estate in the brain are we trying to remodel with our new habits?
Well, we're targeting two primary regions that govern the stress response. The first, as we mentioned, is the amygdala.
The emotional processor.
Exactly, the core of the X system. It's where fear, learning that ingrained emotional memory of a threat, creates these direct, rigid neuronal associations.
So every time I learn to fear something, whether it's a spider or, say, public speaking, a connection is reinforced in the amygdala.
That's right. It acts like an emotional amplifier. The second key target is the prefrontal cortex, especially the medial prefrontal cortex, or MPFC.
And that's our C system structure.
The crucial one. It supports self-regulation and emotion regulation. So our goal is really twofold. We want to reduce the abnormal hyperactivity or even growth in the amygdala,
Okay.
while simultaneously strengthening the functional connectivity and even the volume of the MPFC. We want the commander's desk to be bigger and better connected to the alarm center.
And the reverse of that is the danger of chronic stress, right?
Yeah.
If the stressor just stays on, what happens physically?
Prolonged stress hormone elevation is a powerful physiological phenomenon.
Yeah.
It actively leads to abnormal cell growth in the amygdala, making the fear center physically larger and more active.
Wow.
And at the same time, it's causing neural damage in the PFC.
Mm-hmm.
So you are literally undermining your self-regulation abilities just by being constantly stressed.
So when people say, I just can't think straight under pressure, that is a biological truth.
It absolutely is.
The fantastic news, though, is that the sources repeatedly confirm that removing the stressor and beginning these resilience practices can and does reverse these neural impairments.
Yep.
We're not stuck with the brain we currently have.
Not at all. It's malleable.
So if the brain is malleable, what do we actually do? Let's start with the big gun. Focused mental training. The research you shared looks specifically at secular mindfulness techniques.
Right. Things like mindfulness-based stress reduction, or MBSR, and mindfulness-based cognitive therapy, MBCT.
And these programs are highly structured.
Very. They rely on standardized, evidence-based protocols, focused attention, open monitoring, breathing meditation. And the sources are really explicit that the goal is not metaphysical attainment.
It's not about reaching nirvana.
No, it's practical, pragmatic, emotional coping.
And here is a striking finding that should catch the attention of anyone trying to gain these skills quickly. The literature shows that participants who complete the standard 8-week MBSR program,
Just 8 weeks?
they demonstrate functional and structural changes in their brains, similar to those observed in studies of traditional long-term meditators, people who've practiced for years.
That finding on the speed of change is a powerful testament to structured intervention. I mean, 8 weeks is a commitment, sure, but the neuroplastic reward is just massive.
Let's break down those documented changes because they really trace that C system taking control. We see increased activity and connectivity in the prefrontal cortex, naturally,
Of course.
but also in the cingulate cortex, which is deeply involved in monitoring internal conflict and self-regulation.
And we also see changes in the insula, which is fascinating because that's the part of your brain that tells you what your body is feeling, the physical sensation of stress or joy.
Oh, that's interesting.
Yeah, so by strengthening the insula, you are improving your interoception, your ability to read your own physical state, which is crucial for managing rising anxiety before it overwhelms you.
And what happens to the panic button, the X system?
That's the most critical part. The amygdala demonstrated decreased functional activity. The alarm wasn't just quieter, it had less energy to sound off.
And the connection.
And more importantly, it showed improved functional connectivity with the prefrontal cortex. This is the C system actively establishing the better communication lines it needs for successful emotion regulation.
Moving beyond focused attention, let's look at pathways that are deceptively simple. Environmental exposure.
Right. We've long believed that restorative environments, like nature, improve mood and well-being. Now we have the neurobiological mechanism confirming it.
So what exactly is happening when we walk into a park versus, say, walking down a busy, crowded street?
Well, studies tracking brain activity show that walking in natural environments resulted in significantly reduced amygdala activation compared to walking in urban settings.
So it's direct physical proof.
It is. It's direct proof that nature exposure dampens emotional reactivity and actively helps the brain recover from stress. It is literally hitting the reset button on your alarm center.
That's incredible. The environment itself is acting as a neural dampener.
It is. I should mention an interesting nuance from the research. In one specific study, this reduction in amygdala activity was significant only among female participants.
Oh, really?
Yeah, which suggests important, if not fully understood, individual or gender differences in neural sensitivity to environmental stressors. It's a good reminder that while the principles are universal, the responses can vary.
We should also give the listener a benchmark. The sources suggest that spending at least 120 minutes a week in nature is strongly associated with higher well-being and better health overall.
A very clear, measurable goal.
You can put that in your calendar.
Yeah, and why does nature work so well? There are a couple supporting theories that connect this to the bigger picture. The first is prospect refuge theory.
Prospect refuge.
It suggests that humans prefer environments that offer both open views or prospects and places of concealment or refuges. It's an ancient evolutionary preference for safety and observation.
So we're subconsciously seeking out environments that just feel safe and manageable.
Exactly. The second is the perceptual fluency account hypothesis, which basically posits that natural settings, trees, grass, flowing water, have these complex yet repetitive fractal patterns that are just easier for the brain to process.
Easier than a city street.
Way easier than the dense, unpredictable, and highly contrasting visual input of a modern urban streetscape. That ease of processing reduces cognitive load, and that frees up C-system resources.
And now we move to the foundational day-to-day habits. These often seem simple, but the research confirms they are powerful resilience strategies because they trigger the most fundamental neuroplastic changes.
They're absolutely the bedrock.
Yeah.
When these fail, the more advanced coping techniques often collapse.
Let's start with exercise. The sources describe physical exercise as a form of self-regulated toughening. What's it doing in the brain, chemically speaking?
It boosts a critical protein called brain-derived neurotrophic factor, or BDNF. Yeah, think of BDNF as fertilizer for your brain cells. It mediates neuroplasticity, connectivity, and survival, especially in the hippocampus, which is vital for stress regulation and memory.
So aerobic exercise, specifically.
It is a powerful tool for enhancing neuron production. You're physically building a better substrate for resilience.
And if exercise is proactive construction, I guess sleep is the preventative maintenance, which we often sacrifice first.
And it comes with such a steep neural cost. Sleep deprivation is a severe stressor. Skip just one night of sleep, and the next day, you'll have an exaggerated amygdala response to negative images.
Just one night.
Just one. And what's more, the functional connection between that amygdala and the prefrontal cortex is measurably reduced. You have physically compromised your ability to regulate your emotions over a cup of coffee.
So that recommended 7 to 8 hours a night for healthy adults isn't just about rest.
No, it's about neural integrity.
Social connection seems to work on the structural side of the equation.
It does. For a social species like us, lack of connection is registered by the brain as a threat. But the inverse is powerful. Perceived social support is positively correlated with MPFC cortical thickness.
So it physically makes the commander's desk stronger?
Yes, and it's negatively correlated with amygdala volume. The sources even noted that social reintegration can reverse the adverse effects of prolonged isolation on brain integrity in adult rodents. Social bonds are literally structurally protective.
And finally, expressing gratitude. We hear about gratitude journals, but what's the neurological basis for why that actually works?
Gratitude is a cognitive shift that requires you to actively look for the positive. There was a powerful example where a simple 1-hour thankful letter writing exercise resulted in increased activity in the MPFC 3 months later.
3 months later.
3 months. It wasn't transient. The physical activity in the Emotion Regulation Center was sustained long after the pen was put down.
Let's turn now to the active cognitive strategies. The central unifying theme across all these techniques seems to be that engaging with or confronting a stressor is generally more adaptive than passive avoidance or suppression.
That's the key takeaway.
I want to challenge that slightly. If I have a terrible day and my gut reaction is to simply avoid talking about it, isn't that sometimes a form of temporary self-protection? How is avoidance detrimental?
It's a fair point. Temporary self-protection is fine, but long-term passive avoidance, freezing, not engaging, it reinforces the X system's decision that the environment is unsafe and overwhelming, which limits learning.
I see.
Active coping, however, involves taking action to reduce harm, and that actively rewires the brain. For example, active avoidance, physically getting up and walking out of a room that makes you anxious, that recruits the MPFC to suppress that amygdala-based fear response.
So you're training it.
This active use of the PFC makes the coping response easier the next time. You're retraining your brain through effort.
So if physical confrontation works, what about verbal confrontation?
That brings us to affect labeling. This is so profoundly simple yet powerful. The act of saying out loud or just internally, I feel frustrated or I am sad.
Just naming it.
Just naming it activates the lateral PFC, LPFC. This is the linguistic rational area. And when the LPFC activates, it sends inhibitory signals that reduce activation in the amygdala, dampening the intensity of the emotion.
So the simple act of translating a feeling from pure, chaotic emotion into a rational word shifts its control from the X system to the C system.
Exactly.
Just naming the monster makes it smaller.
It uses language to gain leverage. A related technique is emotional disclosure, like journaling about a trauma.
Right.
The hypothesis there is that this forces implicit, powerful amygdala-based emotional memories to be re-encoded in the neocortex, the C system, making them explicit.
And once they're explicit,
Once they are conscious and explicit, they are accessible for regulation and processing, rather than remaining in the emotional autopilot of the limbic system.
and finally, there's cognitive reappraisal, the classic reframing strategy.
Correct. Reappraisal means interpreting an event in a way that alters its emotional impact. So for instance, you can reframe a public speaking event not as a terrifying evaluation, but as an opportunity to share your expertise.
And that also uses the PFC.
It recruits the same control center, the LPFC, and dampens the amygdala response. The key takeaway is that these cognitive strategies, labeling, disclosing, or reappraising, they all rely on the PFC interrupting and restructuring the input from the amygdala.
We've covered the tools, the mental, behavioral, and cognitive pathways. Now, for the final crucial step, how do we maximize the success of implementing these skills? The sources highlight that certain mindset factors actively facilitate and accelerate neuroplasticity.
This is where psychology meets biology. The first factor is positive expectation, often known as the placebo effect, but, framed here as self-efficacy.
Right.
Expectation has a striking capacity to shape experience. The belief that one has control, even the mere perception of control over a stressful situation, can significantly reduce distress and the activation of pain and distress networks in the brain.
So believing the resilience program will work actually makes it biologically more effective. It's a self-fulfilling prophecy rooted in neurochemistry.
That's right. Your belief primes your C system for success. The second factor is the growth mindset.
The idea that abilities are malleable.
Yes, not set in stone. This is essential for resilience because failure is inevitable. Fixed-minded individuals view mistakes as proof of inability, and they often disengage from training.
But the growth-minded see mistakes as learning data. And this shows up physically, doesn't it?
It does. Growth-minded individuals show greater functional connectivity between the striatum, a region involved in reward and habit formation, and regions critical for error correction in the PFC.
Yeah.
They have a physically enhanced network dedicated to feedback-based learning.
So they learn better from their mistakes.
They recover faster, and they learn more effectively from setbacks.
And the final piece is self-affirmation.
Reminding yourself of your core values, writing about a personal success, for example, acts as a powerful buffer against threat and defensiveness.
How does that work?
Affirmed participants in studies show greater activation in the MPFC and reward circuitry. And this neural response actually predicts subsequent positive behavior change because the affirmation makes the new behavior feel more aligned with their personal identity and values.
Fascinating.
To summarize what we've seen, resilience is not a single muscle you exercise. It's an additive system. The ideal approach involves building a synergistic combination of behavioral, cognitive, and social strategies.
Right.
The consistent biological message is that active engagement, whether cognitively via labeling, physically via aerobic exercise, or environmentally via nature exposure, is the fundamental driver that creates a lasting, positive physical change in your brain structure and function.
And that means you have the power to fundamentally rewire how your brain perceives and reacts to the world. Given that structured mental training like MBSR can produce brain changes in just 8 weeks, similar to long-term meditation, and considering that studies suggest merely understanding the underlying neuroscience of these interventions can measurably improve their outcomes, here is a provocative thought for you.
Okay.
How might intentionally combining a structured mental program, say, undertaking the 8-week MBSR protocol with a mandated lifestyle change, like scheduling your required 120 minutes of weekly nature time, accelerate your personal neuroplastic growth faster and more thoroughly than relying on either method alone? Something to explore on your next restorative walk.